So yesterday we talked about a line, and a line is an infinite string of points. And it goes in two directions forever. And the thing about a line is it is not measurable. We can't measure infinity. Infinity is not a number. Sometimes people think of it as a number, but it's not a number. You can never reach it. It's just a concept. So if you think about infinite, you can't quantify it. You can't give it a number. You can't measure it. It's just forever. So lines can't be measured because they go on forever. So then we talk about line segments, and line segments is a piece of a line. It has two endpoints. It is finite, which means it has a beginning and an end, and it is measurable. Let me see if I can zoom that in a little bit. Sorry, hold on, let me go back. Metric. Now, with metric, you have decimals. With standard, you have fractions. Okay. Metric is nice because of the fact that everything is based on tens. So however many lines you have between the numbers is a decimal place. So like if I was here, I have 2, this is 0.1, 0.2, 0.3, 0.4, 0.5, etc. So that's really nice about metric, whereas with standard units, then you have like halves and fourths and sixteenths and eighths and things like that. So we look at the line, and we have a 4, and our dot is right on the 4. I mean, it's kind of bigger than this space, but that's because I have to make it so you guys can see it. So it's right on the 4. So this is exactly 4 millimeters. So the length of this line segment would be 4 millimeters. Sorry. Yeah, millimeters. Okay. If we come to the next segment, you can see that we're past the 4, and we're lining up right here on this line. So I've got 1, 2, 3, 4. So that's going to be 4.4. So metric is really nice because of the base 10. And while we don't use a lot of the metric system here in the United States, it doesn't make sense to me because it's actually easier than the other. Okay, and here we're at 5 and then 2 lines, so 1, 2, so 5.2. Okay, in standard units, we have on this ruler, I'm going to enlarge it. We have 2 and 3. This line right here is 1/2. Okay, halfway between the 2 and the 1/2 is 1/4. And then halfway between the 2 and the 1/4 is 1/8. So this ruler, the smallest segments are 1/8, but if there was another line here, there would be the 16th. So on a ruler, the smallest lines will either be a 16th or an 8th, depending on how many are between. If there's 4 between the halfway point, it's 8ths. If there's 8 between, it'll be 16ths. And so when you count the number of lines over, we have to count, like, so you have 1/16, you have 1/8, 1/4, 3/8. because 1/4 would be 2/8. Then you have a half, and that would be 4/8. So this is 5/8. This is 3/4, because you have 1/4, 2/4, 3/4. And then you have 7/8. And then 3 would be 8/8, which is a full inch. Okay, so that's how the fractions work on the ruler, and I know how much you guys love fractions. Okay, so here we're exactly 4 inches, so that's nice. Here, when I pull this down, I'm lining up on this line, which was this line, so 3/4. So this would be 2 3/4. 1.5. And that line right there, 7/8. Yeah. And we won't worry about the pencil and the dollar this time. Okay. Any questions on the fractions? Okay. All right. We have what's called segment addition. It's actually the segment addition postulate, which tells us that we can take two segments, and if we put them together, the length of the two segments put together is the length of the two segments added. This is why I told you yesterday postulates are things you just kind of accept as true without proof. It's like if I take this and I put them together, it equals the length of both of them, yet duh, kind of thing. That's why postulates are like that. So what we have to do is to find the length of EG, which is this whole piece here. We have to add the two fractions. Now you'll notice that this EG does not have a line on top of it. If I talk about the line like that, I'm talking about the infinite line EG. If I put a bar over it with no arrows, I'm talking about the line segment EG. Okay, so this is the segment itself. Okay, if I have EG with no line above it, this is the length of EG. So if it has a bar above it, we're talking about the actual physical piece, the actual line segment itself. So if this was EG, this marker, you'd be talking about the marker. If I have EG with no bar over it, you're talking about how long the marker is. Okay, and that prevents us from having to write out the segment EG or the length of the segment EG. You save time by just putting a bar or not. Okay. So now that see this has no bar over it, so this is to find the length of EG. Okay. So I want to add those two fractions together. So I have 2 3/4 plus 5 1/2. The first thing I have to do is change this to fourths. We have to have the same denominator to add the fractions. So to turn a 2 into a 4, I multiply it by 2, so I have to do the top and the bottom by 2. So I have 2 3/4 plus 5 2/4. That's going to give me 7 5/4, but I don't have mixed numbers with improper fractions in them. So 5/4 by itself is 1 1/4. So this 1 gets added to that 7. And it becomes 8 1/4. Now, if you don't like dealing with all of that, moving things around and messing with it, which some people don't, your other option is to take that 2 3/4 and that 5 1/2 and go ahead and make them improper. Okay, so to make them improper, I multiply and then add. So I say 4 times 2 is 8 plus 3 is 11. 2 times 5 is 10, plus 1 is 11. I still need to have a common denominator, so I'm going to multiply both of these by 2. So I'll have 11 fourths plus 22 fourths, which will give me 33 fourths, and that's okay. Improper fractions are allowed. So both of these answers would be correct. This answer would be half correct. It's not completely finished, so you'd lose points on that, but either one of these is fine. So if you don't mind dealing with the improper fractions and maneuvering them and manipulating them, you could do that. If you'd rather not bother with that, you can make them just improper to begin with and add them together and give me an improper answer. That's okay. Okay, finding JL, I need to add these two together, and since those are decimals, it's a little bit nicer. We don't have to worry about all that fraction nonsense. 4 and 9 is 13. I carry my 1, so I get 12.3. Oh yeah, and I forgot my units. Don't forget your units. Add two parts together to get a whole. We can also subtract one part from another to get the missing piece. So if the whole thing is 13.2 and this part is 5.8, we want to find this part. So we subtract this section from the whole thing. Oh, that's a 3. So we have 13.2 minus 5.8. And I'm going to borrow 1 from there, and that becomes a 12, which makes this a 4. And 12 minus 5 is 7. So 7.4 centimeters, or meters, sorry. Here we're going to be subtracting the fractions, and I'm going to do both methods again, the mixed number and the improper, just because, like I said, for me, I don't have a preference. They're both correct. So if you're more comfortable with one or the other, then use that one. So I have 13 and 3/4 minus 6 and 3/8. So I first need to change this to eighths. So multiply by 2, which will give me 13 and 6/8 minus 6 and 3/8. And here's why I hate subtraction with mixed numbers, because if this number was, like, say, a 2, then I have to borrow from the 13 and add 8 and do all sorts of yucky borrowing that we don't like. But 6 minus 3 is 3, and 13 minus 6 is 7. Or I can turn this improper, so I multiply and add. 13 times 4, 48 plus 4, so 52 plus 3 is 55. What? 4 times 13 was 52 plus the 3, so 55. And then I have 6 and 3/8, so 8 times 6 plus 3. 8 times 6 is 48 plus 3 is 51. Okay? So I have 55/4 plus 51/8, and I need to turn this into eighths, so I'm going to multiply by 2. So that's going to be 110 plus 51, 161/8. And that's feet. I left feet off, sorry. So again, either answer I would accept. Okay, so 3 minus 5 doesn't work. Okay, so in order to fix this, I need to borrow 1 from the 10 and turn that into a 9. 1 is the same as 7/7. So whatever your denominator is is what you add to your numerator when you borrow. So if this was a 4, I would have added 4. If this is a 10, I add 10. Yeah, so this becomes 9 and 10/7 minus 6 and 5/7. Now I can subtract it. So the 10 minus the 5 gives me 5, and the 9 minus the 6 gives me 3. Now, if you don't like borrowing, and that's confusing, the other way to do this is to convert these to mixed numbers. So again, we multiply this, and we add it to that. So this will become 73/7, and then 6 and 5/7, multiply and add. So 42 plus 5 is 47. So I do 73/7 minus 47/7, and then I just can subtract 73 minus 47, which that's 6, 26. So for improper fractions, you don't have to worry about the borrowing. You just have to make sure you have a common denominator. With the mixed numbers, sometimes you'd have to borrow, and they're both the same answer. These are equivalent. So if you converted this, you'd have 7 times 3 is 21 plus 5 is 26. They're the same. They just look different. So either answer is fine because they're both correct. So either method is fine. So pick the one that you like better, that makes the most sense, and go with it. I'm flexible in that way. We have to come back to our ability to solve equations. You'll be given this in the form of a sentence. And so my best recommendation is draw the picture and label it. If you draw the picture and label it, it helps you to know what you need to do, whether you're going to add or subtract, how to solve it. Geometry is a very visual math, and we are going to draw lots of pictures. They don't have to be pretty. They just have to be functional. So if you can draw it and interpret it, you're good. So I have find the value of a and xy if y is between x and z. Okay. So I have a segment. I have x and I have z, and y is somewhere in between them. Okay. xy, that's this part, is 3a. xz, that's the whole thing, is 5a minus 4. And yz, that's this little piece right here, is 14. Okay, so what this picture tells me is these two pieces together equal this whole thing. So if I add these two, it'll equal this.
It'll equal A?
This plus this will equal this whole thing, so it'll equal 5a minus 4. So that's what I'm going to do. I'm going to say 3a plus 14, so this plus this is equal to this whole thing, 5a minus 4. Now I have a solvable situation.
Where did you 14 go?
It's right here.
Okay.
So I just put a plus in between those two. So this section plus this section equals this whole thing. Does that get better? A little better, Jamie? Here, hold on, let me try this. If we use some color, this part would be the green part, this part would be the red part, and then the whole thing would be blue. Okay. That's green, that's red, that's blue. Does that help? Yeah? Okay. If not, let me know. I'll try to come up with a better way. Okay. So we're going to take the two small pieces and we add them together to equal the big piece. And now I have to solve this. I can either subtract 3a from both sides or I can subtract 5a from both sides.
Oh, I remember these.
So because I have to get the a's together. If I subtract 3a from both sides, I have positive number because the 5's bigger, but it's on the right, and some people are uncomfortable with that. If I subtract 5a from both sides, it's on the left, but it's negative. Anybody have a preference? The right and have a positive? Okay. So I'll subtract 3a from both sides. These 3a's will cancel each other out. So I have 14 is equal to 2a minus 4. Okay, now I need to get rid of this 4.
And you minus it from over here.
I'm going to add it. Yeah, because if it's negative here, I always want to do the opposite, and I do it to both sides. So negative and positive cancel each other out. So I have, I'm going to move up here to get more room. 18 is equal to 2a. Now this is multiplication, so to undo multiplication, I divide so they cancel each other out. A is 9. So I found A, but if you look back up here, it said to find A and XY. I found A is 9. So that's the first part done. Now I need to find XY. XY is equal to 3A's. So it's 3 times 9, so it's 27. Next example, we're going to find x and bc, so we have to find those two things. B is between A and C, so we're going to draw that. I have A and C, and B is between it.
So if this was written out, like if I was a problem like that, how ugly would it be written?
You could get a picture already, like so maybe given a picture like this and not have it written out, but just have a labeled picture and then been told to solve for A. Okay, so we have B is between A and C. AC, so that's the whole thing. So from here to here is 4x minus 12. AB, that's this little piece right here, is x. And BC, this is that piece here, is 2x plus 3. Okay, so we'll do the color labeling again, if that helps. Okay, so what I have is green plus red equals blue. Like that. So to set this up, green plus red, so I have x plus 2x plus 3. X was green, 2x plus 3 was red, is equal to 4x minus 12. On this side, I have multiple x's, so I need to add those together. And you'll remember if there's nothing there, it's an invisible 1. So 1 and 2 is 3x plus 3 is equal to 4x minus 12. I'm going to subtract 3x from both sides. That'll cancel those. And have 3 is equal to x minus 12. And then I'll add 12 to both sides. So I have 15 is equal to x. And in this case, I did not have to divide by anything because there's nothing there. So I found x, but I also need to find BC. BC is this red segment, the 2x plus 3. So BC is equal to 2x plus 3 X is 15, so I plugged the 15 in where the X was. So I have 30 plus 3. So BC would be 33. Okay, so, and just be aware of that. Sometimes it'll just say find X. Sometimes it'll just say find BC. And sometimes you have to find both. Well, if it says find BC, you have to find X in order to find BC. Okay, in geometry, we have a concept of congruency. And if we talk about things that are congruent, congruent means the same shape and the same size. So, for example, if you had congruent triangles, they would be the same shape of triangle, because you know how triangles can have kind of different shapes, like you can have tall, skinny ones or short, fat ones. Yeah. So they would be the same shape, and then they would be the same exact size, so all the lengths of all the sides would be the same. If you're talking about a segment, well, every segment is the same shape because it's just a piece of a line, you know, so they're all the same shape. So if you're talking about congruent segments, they're segments that are the same length. So equal segments.